Good afternoon, my name is Kathleen Smith. I have a PhD from Yale University and my specialty is zoology.
Hello there, Dr. Tortoise here. My interest is in the field of biomechanics. I received my PhD in biomechanics from the University of Michigan. Go Blue!
Welcome. I'm Daniel Bowden, DVM. I got my degree at Tufts University, and I now work in the New Baldwin Center in Pennsylvania.
How y'all doing? My name is Kevin Kuhn. It's a pleasure to be here. I received my doctorate from the University of Florida, and my special interest is in herpetology, as you can see by my little friend here.
The vertebrate that we'll be investigating today is the giant Galapagos tortoise. These tortoises can weigh up to 660 pounds and live for 150 years. These tortoises are found only in the Galapagos Islands and are mainly terrestrial, occasionally dipping in the water to cool down. It's hard to believe that the ancestors of the giant Galapagos tortoise were the same size as our friend here, Bubba. Bubba is a Russian tortoise. Because of the biogeography and seclusion of the Galapagos Islands, these tortoises were able to grow into the giant size that we see today. Due to lack of competition and predation and abundance of food, they were also able to grow. Some of the tortoises moved to different islands and formed different subspecies, mainly pertaining to their shell. This is the carapace on the top of the shell and the plastron on the bottom. Some of the tortoises on different islands have a domed carapace like the Russian tortoise Bubba has, and others have a saddleback carapace. This allows them to fill different niches of the islands, so a saddleback carapace allows them to feed higher up, and the domed carapace allows them to feed lower to the ground.
We will be analyzing the article Giant Galapagos Tortoises Walk Without Inverted Pendulum Mechanical Energy Exchange, written by Peter Zani and his colleagues in 2005. The general findings of this article explain the mechanism of walking used by the giant Galapagos tortoises.
As we all know, most tortoises use the inverted pendulum method of walking to conserve mechanical energy. The giant Galapagos tortoise, however, does not use this method due to its large mass and size.
The physical aspects of the inverted pendulum deal with the kinetic energy and potential energy, which are inversely proportional. Therefore, as one increases, the other decreases, and vice versa. For those of you who are unaware, kinetic energy is energy of motion, while potential energy is stored energy.
The inverted pendulum method can be explained like this. And for the purposes of this demonstration, we'll be using our lovely demonstrator, Rafaela. So, when walking from heel to toe, once the heel touches the ground, your foot has kinetic energy, and your center of mass is raised. The kinetic energy is then converted to potential energy as your foot lays flat, rolling to your toe. At this point, your center of mass is low, and thus the cycle repeats over and over again during the walking motion. And as you can see, this motion resembles an inverted pendulum.
The Galapagos tortoises have very small changes in kinetic energy due to their slow speed and large weight. Due to the lack of kinetic energy and the vertical thrust applied by Galapagos tortoises, it would be costly to use the inverted pendulum walking method. Consequently, it has been observed that Galapagos tortoises sway instead of keeping the center of mass at relatively the same height. This method is still very energy efficient, and they do not work any harder than other organisms traveling the same distance. Notice how the Galapagos tortoise sways from the front right when he steps down, to the front left, so he's swaying side to side rather than forward and backwards, as in the inverted pendulum. And he also keeps his center of mass relatively level throughout the whole walking method.
Buongiorno, bonjour. Wie geht's? Hola. Shalom. Hello. I am Dr. Schwartz, the biomechanics expert from the University of Michigan, and this is my part in the informational video today on the Galapagos tortoise and the inverted pendulum mechanism walking gait. In order to illustrate the difference in walking gait between the Galapagos tortoise and all other species of tortoise, I need a special volunteer. A special volunteer that is only available at Union College.
Yay.
New volunteer, Stella. Come on, Stella. Up. Stella unfortunately suffers from the boy named Sue syndrome. He's been fighting his whole life, but he'll make it through. He's a good guy. Stella is an African spur-thighed tortoise, or as the folks in the Vatican would say, Giaccolione sulcata. Yes. He is around 30 pounds in weight and approximately 20 inches long. He's been a bit malnourished, but the folks here at Union are taking great care of him, and we'll get him back up to speed in current weight measurements. Stella will live till about 80 or 100 years old. That means the guy's going to be around for another 50 to 70 years. Could outlive us. It's pretty neat. So Stella is going to help us show how other tortoises beyond or besides the Galapagos tortoise walk. You ready, Stella? I'm going to set you down. All right, here we go. African spur-thighed tortoise in motion. This is once again our friend Stella here. As you can see, Stella, like most other tortoises besides the Galapagos, does not have to put up with a massive weight. Therefore, Stella can generate enough kinetic energy to raise his center of mass and move. And he moves his limbs opposite, as in right front, left, rear. Left front, right, rear. Right front, left, rear. Unfortunately, Stella's part is concluded. Stella was a great volunteer, wasn't he? And he enjoyed walking for you guys, and I hope you guys enjoyed learning from Stella's gait. And such great African spur-thighed tortoises need to be rewarded for such great deeds. Guys, come on over. Nice job, Stella. Attaboy. Go ahead and eat. He needs his strength, because today he's walked probably close to 20 laps around this laboratory. It could get pretty strenuous for him. Here are my associates, Dr. Bowden and Dr. Smith. Stella generally eats hay in his kiddie pool. Hay is probably best for him nutritionally. This lettuce, fruits, and vegetables are good, not as good as the hay. And sometimes a certain someone named Professor Pytel will bring in some contraband and really spoil Stella's appetite. I hope you enjoyed our section with Stella today and the African spur-thighed tortoise walking gait. Au revoir, auf Wiedersehen, goodbye.